Hello everyone and welcome to yet another recreation programming session. How about that? I've been working on my music visualizer right before I pressed the record button. So the music visualizer is pretty straightforward, right? You just drag and drop some music in here and it starts doing this FFT visualization. I was trying to improve the design because, as you can see, design kind of sucks, especially the colors and stuff like that. So I was trying to improve that. And then I stumbled upon a bug that I couldn't instantly figure out, so I had to bust out the heavy guns, I had to bust out the debugger, right? So, and I'm not using GDB, pure GDB, I mean. I'm using the GDB frontend called GF, right? So this is the best GDB frontend for Linux I know, right? I really recommend it, by the way. I'm gonna keep the link to this thing in the description. It's open source, it's free. Though there is a couple of cool features behind the paywall, but they're on Patreon, so I also recommend to check their Patreon. But everything that is useful for me is actually free. I would definitely pay for extra features if I had money, so but I just don't have any money. Anyway, so I bust out this thing, and then I stumbled upon a bug in this thing while trying to fix the bug in my own application. So let me demonstrate you, right? Let me demonstrate you. That was rather interesting. So essentially, I'm going to start the debugger. I'm going to start the visualizer, my music visualizer within the debugger. And this is how the debugger looks like. It looks like a proper debugger, actually. Look how quickly it recomputes its layout. Like, look how quickly it does that. Can your Electron do that? I don't freaking think so. Anyway, so, and essentially, what I did, I just started the application from within the debugger, right? So I just started to play the music. And then while playing the music, I decided, okay, so I want to stop the running application in a very specific place while it's playing the music, right? So I just picked the file, and this is the main logic in here. So this is the main loop. And I just want you to see the contents of out, basically the buffer that contains the frequency domain. So I put a breakpoint in here, and it basically stopped, right? So the application is actually stopped. So let me actually put it aside somewhere here. And there is a watch window in here, so you can actually input different expressions in here, and it will evaluate them and it will actually show them. Unfortunately, it's not very easy to change the size of the font like in runtime, but yeah, so basically this is the frequency domain. As you can see, it's essentially an array of complex numbers, right? And then I decided, okay, so I want to look individual things, and there is a triangle in here, as you can see, so I can expand it and see it as an array, and the debugger just crashed, right? It literally crashed. I'm debugging the bug in my own application and counting the bug in the debugger. God freaking damn it. Anyway, and it crashes with not with the seg fault. It crashes with an assertion. So something unexpected has happened. So the invariants of the application were not met. It's a logical bug. It's a logical bug. So, but luckily in assert, we do have a place where that scheisse has happened. So let's actually go there, because the debugger is open source. We can actually debug the debugger. How about that? So let's actually go here. So the line is 67. And here we have an assert. Okay, so overloaded bracket operator. So this is C++, by the way. Right, so the entire thing is written in C++. Yeah, so this is a classical dynamic array, right? So it is templated, and it has a pointer at the beginning of the array. It has the length, how many elements we have in an array, and we have a capacity, so how much stuff has been allocated. And essentially somebody, somewhere, tried to index the array outside of the boundaries of that array. So that's what happened. Right, so, and if we take a look at the assertion one more time, we can't really know where exactly that happened, because this assertion doesn't give us the stack trace. The only way we can get a stack trace is only when we debug the debugger. So yeah, we need to literally run GF, the frontend for GDB, in GDB to acquire this stack trace. So That sounds like an interesting content, so let's just go ahead and do that. Right, so let me see. So as far as I know, so this is the visualizer. It's completely stuck, as you can see. So it's just doing these trails, the classical trails when the application is not responding. So, but as far as I know, we can't just kill it, right? So because it's stuck with GDB, right? So because the JF frontend runs GDB and GDB runs my visualizer, we crashed the frontend. So GDB is still hanging in the memory and it's dragging the visualizer with itself. So the easiest thing is to kill all of the GDBs and everything is fine now, right? So we don't have a visualizer anywhere in here. So here's the idea. I'm going to be doing GDB. I don't even know, did I build the how is that called, the GDB frontend with the debug information? I don't actually think so. So here's the source code of GF, right? And it's actually a very simple application. It also has like build.sh script, right? And in here, like to build the entire thing, you just have to issue like a single command line, right? So it's a very simple, you know, frontend for GDB. And I think it does supply the debug information, right? I usually prefer to do ggdb. Maybe just minus g is enough, but just in case I'm going to do ggdb. And I'm going to rebuild this entire thing, right? So let's just rebuild the entire thing. So it has a couple of warnings and stuff like that, but who cares? Who cares about the warnings? What's important is the application actually working. Well, I mean, the application is crashing, so... maybe if we fixed all of the warnings it wouldn't crash. I don't know. Okay, so let me try to run it with GDB. I don't want to run it in itself because it's crashing, so I don't know what kind of bugs I will encounter. Maybe I won't be able to debug it, right? So it's kind of, you know, doesn't sound good to debug the debugger in itself while it's also crashing. So I think we need a little bit more reliability in here, if you know what I mean. So let me start the debugger in here, right? So there you go. And I want to run the debugger, but I want to run it with visualizer as a command line argument, right? So, okay, so we've got that, so which is pretty cool. And I'm going to replicate my situation one more time. I'm running the visualizer. So one more time, we're running visualizer within GF, within GDB, right? So we have two layers of debuggers in here. It's quite important to remember, like it's a mental gymnastics that we have to be aware of. So let's start playing this thing. Okay, so let's go and stop the application at a particular place while it is still running. So there you go, it now stopped. And then I'm gonna try to do out, right? So here I've got the array of things. I'm not sure if you can see that. So the watch window is located in a very inconvenient place, but anyway. So I'm gonna try to expand it. And it already crashed as well, so as you can see, it's just like we have two crashing windows actually. So we have a crashed visualizer and crashed GF. Well, I mean, visualizer is not really crashed; it's just like stopped by crashed GF2, right? So we have two kind of not responding applications. It's kind of funny actually. Right, but let's take a look at the GDB, right? So now I can do backtrace, and here is the stack trace, right? So we have an assertion in here, and it failed at the function called watch insert field rows at the line 1206 at the file windows.cpp windows, but I'm on Linux, right? So what the fuck is that? All right, so let me take a look at this thing. So this is where it failed. And right off the bat, like, why are you directly indexing an array when it can actually go out of bounds? That is kind of sus, my friend, right? Like, obviously, if the array is empty, it's going to crash. So what are they trying to do in here? So they basically assume, right, so that the function in here, it will populate the array, but it will populate it at least with a single element. So then they can do this kind of thing. So they can insert many. Oh, this one is interesting. Okay, I see what's going on. This is like a very common thing, at least in C. They're taking a pointer at the beginning of the array, and they passing it to a different function, but along with the pointer to the beginning of the array, they supply the length of the array. And since the length of the array is 0, the inner function is not going to even dereference anything within that array, so it is totally fine. But the problem is, this code didn't take into account that the brackets are overloaded, and that thing 100% will dereference that element. Which is quite interesting, actually. So if you have just a pure vanilla array, like access, or something like that, and you do something like access 0, that will dereference the pointer to the array. But then if you take just a pointer to that specific element, that won't dereference that element. But in C++, if the brackets are overloaded, the operator brackets will be still called anyway and potentially dereferenced anyway. So that problem may occur only in C++ because in C++ operator brackets is overloadable, and it is overloaded in here. Okay, so it's just like, it's basically when you try to program in C++ while being a C developer, right? Because from the C point of view, doing something like that makes sense. It does make sense, but in C++ it may break if you overload operator brackets, and this is exactly what is going on in here. Okay, that's really interesting. So can we find the definition? Can we just like get the pointer that is inside of the dynamic array? Right, so I just want to find grep struct array, so where we had that struct array, and so it uses struct, so everything in here is public. Thank you very much. So that means we can just, yeah, we can just take this array, I suppose, and just like supply it in there. All right, so that means instead of doing that, we probably want to do something like this, and that should eliminate the crash, hopefully. Right, so that should eliminate the crash. Let me try to rebuild this entire thing and see if it's still building. Okay, it still issues a lot of warnings, but I mean, hopefully it will work this time. Okay, so let me close everything in here. I'm going to close the GDB. So we still have Visualizer, and let me see, do we still have another GDB? Yeah, we do, so let's kill all of the GDBs. And let's try to do that one more time, right? So I'm gonna go to the Visualizer. I'm gonna start GF2 and Visualizer within it, right? So this time we're not gonna have two layers of the debugger. I'm gonna run this entire thing one more time, and let's start playing the music. Go here. Where's my FFT? Boom. So then. It's gonna be out, and let me expand it. Okay, it didn't crash, sure, but it didn't populate anything either because the array is empty. Okay. At least we got rid of the crash, but I mean it doesn't work correctly. So I suppose you know, the real fix would be to figure out why it is not populated, right? So maybe that's what we have to do, but I just don't feel like doing that. I thought it's going to be like a very quick and easy fix, and now I have to go into like very dirty, deep implementations of GF2. But maybe it's not that very deep and not that very dirty, so let's actually give it a try. So let me see, so Windows, let me see why it may not work. Right, so let's find this specific thing. Okay, so it's literally nearby, and it's something recursive, as you can see, because it calls to itself. What we're doing, we're supplying the watch, right, and we are iterating through the fields of the watch, and we're adding the fields of the watch to the array. So that means the only way this array can be empty is only if the watch doesn't have any fields. Right, so it actually goes a little bit deeper. We can try to maybe go and like debug that one more time. But this time, since it's not like GF2 doesn't crash anymore, right? So it doesn't work correctly, but at least it doesn't crash. We can do that in itself, right? So let's give it a try. I think it's kind of interesting. So I'm going to close this kind of thing. So since nothing crashed in here, so I think there is no GDB, so there's nothing to kill, so that's fine. All right, so we are inside of GF2. Right. So I wonder, is there any way to maybe make it more reproducible? Because like starting visualizer like this and like playing the music all the time is not particularly convenient, right? So maybe it doesn't work for any of the arrays. So let's actually try to confirm that, right? It would be nice to have like a minimal reproducible example. So let's actually create main.c, so let's do the following thing, right? So we're gonna have something like that. And let's create a global array. And let's say that we're going to have 5 elements in that specific array. Right, so let's actually try to do that. So let me do clang o main.c, and then I'm going to build that with the debug information. Right, so if I try to run this entire thing, okay, so that seems to be working. So now if I do gf main, right, so let me just open this entire thing. I'm gonna stop in here and I'm gonna just run this entire stuff. So the debugger has stopped. Let's take a look at access. Okay, so here we can see the access. It's 1, 2, 3, 4, 5. I try to expand that. Okay, so it doesn't work with any of the arrays, which is actually good news, right? Because I don't have to start my clanking visualizer. I just can use this specific application to actually like debug all that stuff. That's pretty cool. Anyway, let me go and try to debug the debugger, right? So I'm gonna do gf2. It's actually kind of fun. I wonder how often you have to do something like that when you're developing a debugger. Right, we're debugging the debugger with itself. Kind of funny. So let me actually do it like that. So there we go. And what do I want to do? I want to find this specific place, right? So it's going to be 1196. I wonder, is there any way to quickly jump to a particular file? So there's a way to sync with gvim. I have no idea what that means. Inspect line. So expression. Okay. So no expression to display. Press skip to line mode. Okay. Maybe there is a way to jump there. It's just like I can't see that. Maybe there is even, you know, an action in here, but I'm just blind. Especially when I'm streaming and recording myself, I usually become more dumb than usual, right? So okay, so let's actually go 1196, right? So 1196. I could have actually maybe just done the following thing, because we have a GDB prompt in here, so I can do break, and I just like, yeah, there we go. So it works as well. So what I want to do, I want to just like look at the backtrace and see where this particular function is called, and also what's inside of the watch and stuff like that. I think it's going to be interesting to actually look at. All right, so I'm starting the you know, GF2, but I'm starting it with the executable of our testing application, right? So boom, and we have a second layer, we have a second GF, right? So, and that GF is being debugged with this one, right? And in here, what I need to do, I need to open our test application. I'm going to put the breakpoint in here, right? So I'm going to do the run. Okay, so it broke in here, and now what I'm going to do is I'm going to run access. Everything seems to be working, so it didn't break yet, and I'm going to try to expand this thing. Nothing happened because it stopped responding, right? It does not respond anymore. The second debugger does not respond. And we've got something in here, right? Length. Why are we at length? Excuse me? Why are we at length? That's really, really weird, right? Because I thought, where's the breakpoint? So this is the breakpoint. I suppose this is where we stopped, right? So can we see the watch thingy? Okay, so we can't really see anything. Let's try to step at least one time. Okay, so we stepped one time and we already have a watch. And inside of the watch, right, so we're iterating through the fields. And do we have the fields? Okay, so here are the fields. And as you can see in the fields, the length is straight up 0, right? So it's just like no fields are in that specific watch. No fields in that specific watch. I wonder if there's Where is the stack trace? Okay, so here is the stack trace. That's actually very cool. So obviously it is called within that thing, so that is understandable. And that thing is called within watch window message. All right, so that's very interesting. So we've got that sort of watch in here, right? So we got that watch, and we get it from W, and that W is what? Okay, so let's actually go here. What file are we currently in? So it's a Windows CPP 1875. That's where we are at right now. So what is W? I'm actually really curious what is W. Maybe I can inspect W. Okay, so it optimized the because we're inside in here, so we can't really go in here. So I wonder if we can. Okay, I remember that, yeah, there was a feature, pretty cool feature, right? Basically, you press Shift and you can skip everything up until this point. I wonder if that is going to work. And does it work? It didn't really work, so I don't think it's easy to do it like that. Right, so where are we though? I don't really know where we are. Okay, so let me try to continue. The program is not being run. Okay, so I accidentally quit it. Anyway, so let's try to see what is, you know, this small w. Usually with a name like that, it is probably an argument of some sort. Maybe it's an argument for this huge function. Right, so, oh, okay. So it's a watch window, right? It's a watch window. And we take the watch as one of the rows from the watch window. Okay, so that means it's one of the rows. So we probably want to find the definition of the watch window, I mean. Let me try to do grep watch window. It's probably struct, right? Okay, so it is in fact struct. So here's the rows, and rows is an array of watches. Okay, so that's pretty cool. That's pretty cool. So one of the things, but where is the definition of watch? What is the definition of watch? Right, so what we're interested in is why the fields are not populated at all. Why they're not populated at all. So who populates them? Right, so the place that populates the fields should have probably something like fields dot, because it probably calls something like add to the fields, right? Because it's an array, so an array has the method add or something like that. We can even try to do it like that, right? So basically grep fields add, and there we go. So we found two places where this kind of stuff is populated, right? So there's a watch, and that's what's going on in here. So this is where we populate this entire thing. Watch add fields. Okay, so that's actually pretty cool. And what is going on in here? So watch loaded fields. I suppose it's some sort of a cache, right? Basically, it doesn't add the fields if they were already added. And then, of course, it puts true in here, right? So indicating that it's sort of cached already. Watch evaluate gf fields. And then it takes the evaluate result. Where is it even defined? Is that a global variable of some sort? It must be some sort of a global variable, right? Because I can't really find it. Evaluate result. And then if it's array or d-array, it just starts doing these things. And, right, so where do we do the fields? Right, we allocate... Okay, so we allocate the fields for the watch. And we have the count. And the count is extracted from evaluate... What the hell is going on in here? What the fuck is this shit? That is cryptic and bizarre. So we definitely have to look at this specific thing. We have to break in here and see what the fuck is going on in here, because this is freaking bizarre. This is going too deep. Okay, so let me actually close everything, right? So okay. So let me see if we still have some GDB scheiße. Okay, so let's kill all of the GDBs and let's do gf2. gf2. I'm in the wrong place. God fucking damn it, mate. God fucking damn it. Okay, so let's do that one more time. All right, so can we now break at that specific function? Watch add fields. Okay, so we're broken here. Where's the breakpoint? So here is the breakpoint. I think it is the correct place. Very, very good. Yes. So now I run with the test application, right? So this is the test application. There we go. Within the test application, I want to actually break at main, right? So where are the breakpoints? This is actually kind of cool strategy. Essentially, use GDB prompt to break at particular function if you know the function name, and then through the breakpoint window, just jump in there. It's actually a pretty cool strategy, okay? Anyway, so here is the first GF2, here's the second GF2, I'm running the second GF2. Right, so we actually hit the breakpoint, and I'm about to take a look at this specific thing. So nothing actually crashed or broken, so far this function was not called. Right, it was not called, so it sort of adds these fields lazily. I suppose I'm going to try to expand this entire thing. Boom. It does not respond, right? It really does not respond. As you can see, it's leaving trails. And we hit this entire thing. And this is bizarre, meine Freunde. This is absolutely bizarre. Like, what the fuck is going on? So here is the watch. What do we have in here? So open true, has fields true. Loaded fields is false, so we have not loaded fields yet. So we are checking that. So that means if I do this step, it will fall through. Then it will mark that the fields has been loaded, and then it will try to do something called watch evaluate with a string literal GF fields. Right, so that's what it's trying to do. Watch evaluate GF fields. What the fuck is that? So let's actually try to step in and see what is going on in there. Okay, so the first argument, that string literal, is apparently a function. Maybe we're actually calling some sort of like a function of GDB, right? Because maybe we're sending it to the prompt of GDB, because how does GF2 and GDB interact with each other? They probably, maybe through the standard input output, maybe GF like literally sends commands in there. Right, and just like parses the outputs or something like that. But anyway, so the first thing we do is, okay, we have a buffer though, right? So we have a buffer, like 4 kilobytes of buffer. So we also have a position, and I suppose this is the position to track within the buffer. So filling up some sort of a buffer. Are we filling up like a command that we're gonna send to GDB or something? Probably. So a string format, okay. So buffer plus position, that makes sense. So we just add in some stuff at the end of the buffer. Ooh, pi. Is that a command of GDB? Really? GDB, is that the command that we're sending in there? So, oh yeah, freaking, I remember. GDB has an ability to evaluate Python. You can actually script the GDB with Python. Oh, okay, so the way GF2 probably works, it has like maybe a bunch of Python functions specific for GF2, right? And basically it loads them, it evaluates them for GDB, right? And then it calls those functions for GF2 specific things to extract maybe GF2 specific information. So yeah, Python is a shader language of GDB. It's funny because like just before this session, I tweeted a really dumb shit. Just a sec. I tweeted that SQL is a shader language of database. Right, so it's an old joke that I came up with like a long time ago, because right, so you have a separate language and you write a program in that separate language and you sort of like upload it on a separate service to do things in there, and it kind of reminds me like GPUs and shader languages and stuff like that. So here we have Python, and Python is the shader language of GDB. All right, so is that something you can like literally do? If I run GDB, right, so and then I do pi, okay, can I do 69? Okay, so maybe I have to like provide, okay, it didn't do anything. So can I do print your mom? Okay, so wait, I don't have to use the shaded GDB commands. I can just like, can I do everything through Python in here? Yo, what the fuck? So that's actually pretty cool. Anyway, right, so can I do things like this? It doesn't print, like you have to use the print thingy. Okay, that's actually pretty cool. Holy fucking shit. Anyway, so we're trying to construct some sort of like a command or whatnot. So let me actually keep track of this buffer. Oh, okay, so we're in the wrong place, I suppose. Yeah, so here is the right thing. And let's take a look at the buffer. So the buffer contains gibberish right now, as far as I can see, so it doesn't really contain anything interesting. So let's make a step. And now the buffer contains this thingy. So since we have a position, right, so let's take a look at the position. Position is 14, and this is basically how many characters we have in there. So I wonder if we can do something like position, and how can I don't quite remember. I think it's like a buffer. You dereference it, and then you do position. Yeah, okay, so that's how you do that. Essentially, if you have an array, right, you can say at and the amount of elements, and the GDB will display this amount of elements. And if the position changes, this entire thing will grow over time. Right, it will grow over time. Okay, so that means we'll see more and more stuff as we construct it. Right, so here we have some sort of a stack. I hope it's not gonna go for too long. So another stack. Okay. All right. Do we have more in here? I don't really see anything. But in any case, what we're doing in here, we're calling GF field function anyway, right? So maybe, yeah, it doesn't really do anything useful, right? So then if we evaluate the buffer, debugger send, okay. So, and then we're literally sending that thing. Okay, the program is running, evaluate mode. So we're logging the mutex. Okay, that's very interesting. Program is running. So that means we have several threads. Okay, so we do in fact have several threads in here. So here are the threads. Okay. Traffic light. That's a very funny way to call like some sort of synchronization primitive. All right. So then we parse the new line. So do we have anything to look at? So we have a string. I don't freaking know. But anyway, you know what I want to do? You know what I want to do? I want to find where that specific function is defined that we're trying to call. Right, because we're trying to call a very specific function. We're trying to call function GF fields. Right. So what is going on in there? Right, so what is going on in there? So let's find GF fields. GF fields. Okay, and we instantly see def, we instantly see Python. Oh. This is literally freaking shaders. Because shaders quite often, for the simplicity, they're stored in some sort of a string literal, so then they can be compiled with like GL shader compile and linked with GL program link and stuff like that. So okay, so all of the Python code that is being like injected into the GDB is just like a single string literal, and I suppose this like watch evaluate thingy, it just like accepts the function that you want to call, and it calls one of these functions from this script. I suppose that's how it works. Very interesting approach, not gonna lie, very interesting approach. But I mean, I don't know if you can do it better, right? So because I never implemented like a GDB front ends in my entire life, maybe that's how you're supposed to do that. Kind of makes sense. GF fields. Do we have GF fields? And here is the GF fields. We pass some sort of expression in there, then we do GF value on that expression, and then we return something in there, and it's just like we're just looking up some stuff where it doesn't really make any sense. Anyway, so you know what I want to do? I want to actually take a look at the evaluated results, right? So Okay, let's actually skip everything, right? So here is the, we are inside of the debugger send. We're about to send the GF fields function. Let's take a look at what we've got in there, right? So this is where we call, and I'm gonna like literally skip up until here. Right, okay, so we already sent the command, we probably received something, so some of these things are not needed anymore in here, whatever. So we are comparing evaluate result, or let's take a look at evaluate result. Okay, so we've got something in here, which is nice. Evaluate result, so it contains like this value, right, it contains this value, which is nice. All right, so let's go further. Right, so, and we went to a very weird place. Wait, did it crash? Did it just crash? I think my second debugger just crashed. Maybe it went to some sort of like a weird... Okay, maybe we were waiting for too long, right? Because we have several threads. One thread's like listens to GDB and stuff like that, but I think this entire thing has died. Right? It's not running even. Okay, so let's give it a try. Let's try to run it. Where are all of the you know, breakpoints? Let's do run on main. Okay, so that seems to be working. So let's go back. Okay, so let's break in here and let's run this entire thing. Okay, and I'm gonna do access a boom, and then I'm gonna expand this entire thing, and we are in here already. So let's just step through all of this stuff. We evaluate this entire thing, and this time we got something different actually. That's very interesting. So we got a string that contains parentheses, array, and 5L. All right, so let's go further. So this thing checks whether evaluate result contains parentheses array or parentheses array. And that is the case, right? So the result of the evaluation from GDB does contain parentheses array. Dude, this looks very flimsy way of doing this kind of stuff, right? So you are connecting to the standard input-output of GDB, you upload some Python scripts, and you rely on the correct formatting out. But I mean, I don't know how to do that better anyway, so I'm not gonna pretend like I know how to do that better. So it's just like it is what it is. Okay, so the next thing we do evaluate result +7, and we're converting that to an integer. And count. Oh, and a count is the thing that is used to allocate enough. Okay, we're trying to extract a number out of that, but where is the number? Okay, so yeah, okay. We're trying to extract a number. Did we manage to do that? Okay, so let me take a look at the state of the count. All right, so it optimized out. I don't know. It couldn't extract the size of the array. Right, so, okay, so we get the type of the expression from the Python script, and it is array, and the size of the array is 5. And then we're trying to extract that out of the string, and we couldn't freaking do that. It's 0, and that's why it doesn't display anything, because it couldn't parse the output from the Python script from the GDB. All right, but why couldn't it parse it? Right, so can I copy-paste this thing? So copy value. Okay, I can just use Control-C apparently. Can I do that? All right. So the string is, if I understand correctly, this is the string. This is the string literal that we have in here. Right. First, we do what? We see if it contains array. Right. So a stir is basically substring. Right. So do we have that substring within the string? Locate a substring. Okay, so that makes sense. And then we add the 7 to the string, and then that means the string should start with a number. I'm gonna actually go forward 7 times. And yeah. So this is a really weird code, honestly. Right, it would make sense if the output was, I guess, something like this. Right, if it didn't contain any of that stuff. In that case, if I go forward 7 times, I land exactly at the space, and A2I should be able to handle the spaces, and it should be able to extract all of that. So I feel like this is the output that the GF2 expects, and this is what we get, right? So we expected this thing, but we got the tuple. This kind of thing may happen in Python if you do something like print array and then 5L or whatever, right? So it doesn't even work, so maybe just 5. Am I right, Python? So this is Python 3. I don't really know. So, okay, so yeah, if you print it like, okay. So maybe somebody modified the Python script but forgot to modify the C code. Maybe something like that has happened. Right. So let's take a look at the Python scripts. Right. So do they even print anything anywhere at any point? Right. So do they do the print? Okay. So this is one print they do. So the print value. Oh, would you look at that? But wait a second. I mean, if in Python, if I do this thing without the parentheses, it would just print it like that. There's no parentheses in here, so it should not be a problem, like whatsoever. What? Wait a second. Is that like something with GDB? So if I do print, let me try something like this. So something like array. Okay, so that makes sense. And then look at this motherfucker. Why the fuck are you do that? Why? It is not even compliant with the freaking Python. Like, is this the same Python? Is this really the same Python? What version of Python is that? Maybe it's Python 2. I do have Python 2 somewhere. Okay, so if I do that with Python 2, right? It's a freaking Python 2. Well, I mean, okay, I can only blame myself, right? Because I'm using Debian, and probably my you know, GDB is so old that it's literally using you know, Python 2, right? Is that correct? Okay, so I was just like looking for 9.2. So I remember that GF would check for the version of the Python, wouldn't it? GDB is not detected. Man, okay, so at what version GDB switched from Python 2 to Python 3? That is very interesting. Okay, so let me see what we can do. So Python 2, okay, so we know that it's a Python 2. How can we do string formatting, like Python 2 string formatting? I don't remember how to do that, so let me see. The Python string formatting best practices, realpython.org. It's actually .com. So if I remember correctly, these days you're supposed to use like these like F strings and stuff like that, but we're talking about Python 2. Okay, so here is the old style string formatting. Let me tell. Oh yeah, the percent operator. I do remember that, right? So like I don't really program in Python very often, so sometimes I forget shit. Okay, so if we have something like array 5, it does this stupid scheiße. What we want to do instead, right? So actually we want to do something like parentheses in here. We probably won't put space in here and put D, right, and then put something like this in here. And the cool part is that it should also work in Python 3. It works in both of the versions of the Python. Right, so maybe we can just go ahead and modify this entire thing to work like this. Okay, so this is going to be D. And then I'm going to put like this. So we have +1 in here, just in case I'm going to put parentheses in here. So do we have any other places where we have... Okay, so... All right, so this is literally the only questionable place with print and stuff like that. Okay, good. So for the rest of the things, let me go through all of the prints one more time because I'm not freaking sure. So print... Yeah, I feel like this was the only questionable place. I think that was literally the only questionable place. Okay, so let me close everything. So I'm gonna close this entire stuff. Let me double check if we still have some GDBs. Grep GDB. Okay, so we have a lot of GDBs actually. So let's kill all of them. Let's kill all of the GDBs. I'm gonna rebuild the entire Scheisse. Cheers, by the way. Alright. And let's actually go ahead and start like a regular GF2 with the test example, because I feel like it should fix it. I feel like it should fix the problem. Right, so let's go to, let's just like straight up break main, and then I'm gonna go to the breakpoints, and there you go. And I'm gonna take a look at access, and the moment of truth. Can I just expand it? Fuck yeah. First try, motherfucker. So yeah, that was the actual freaking problem. Sorry. Wow, that was very interesting. Okay, so all right. So I feel like this is a relatively safe change. Right, so I know that on the modern software it shouldn't happen, right? Because the modern software, Python 3, it just like works correctly. But I think it's relatively safe to just do it like that and add support for Python 2, right? Because it doesn't cost anything, right? Seriously, like doing it like that doesn't cost anything. It should work on Python 3 anyway. Right, so yeah. Let me see if that works with the Mutualizer, right? Because I want you to try to use that on the Mutualizer. Okay, so I'm gonna do this kind of thing, software, GF2, build Mutualizer. We're gonna do it like, I'm supposed to actually do that in a slightly different way. There we go, yesu. Okay, so I'm gonna run the Mutualizer, right? It starts the thing, let's play some music, and let's go to the plug C. Let me find the FFT place. Boom. Okay, so now I want to take a look at what we have in the output buffer with all of the frequency in the frequency domain. Okay, here are all of the complex numbers. Can I expand it? Look at all of these frequencies. Oh my god, this is so cool. This is so beautiful. Oh my god, it's just like, finally. Okay, we fixed the debugger. Now I have to go and fix my application. Maybe one of the things we can do in here is probably, submit a pull request of some sort, right? So submit a pull request. So let me see. What kind of changes do we make? I don't think we made too many changes. Right, so there's some changes in build, but it's my own local changes. So we changed this thing, for the Python, and here we changed. Okay, so this is two separate things, but they kind of like solve two separate problems, I suppose. The problem in Python was not visible, at least on my machine, before I fixed this thing. So it's two separate kind of things. And maybe we should have two separate commits for them, right? You know what I mean? Maybe we should have two separate commits. Let me create this kind of thing. So we're going to create a separate branch. And what should I call this branch? Fix crash. Fix crash on arrays, right? Fix crash. This is not how we do that. Okay. Fix crash on arrays. All right, so this is going to be the first one. So this is the first thing. Get a pointer to the beginning of the array properly. Maybe safely, right? So essentially what we need to do is get a pointer to the beginning of the array without dereferencing the first element. And it would be nice to maybe explain why exactly we do it like that, right? So the operator brackets is overloaded for array t. So array 0. Okay, so it starts highlighting this kind of shit. So maybe it would make sense to put backticks in here. You know what I mean? Is it gonna make it less weird? I don't think so. Right, so I was hoping that it would use markdown mode. Okay, so, but I mean, it's gonna display on GitHub fine, right? So is overloaded for array, so array will always call to the operator function and hit the out of bound assert check there. So so if the array array or structure, if the array or structure didn't have any fields, let's put it like this, does not have any fields, it always crashes. Right, so the tenses in English are kind of difficult. So if the array of or if an array or a structure, so we're not we don't know what kind of array or structure we're talking about. If an array or a structure do not have any fields, it always crashes, right? It always crashes. The operator is overloaded for so array always calls to the operator. So I'm trying to like use the tenses how I would do in my native language, so that's why it sounds weird, right? So I really apologize for that. Okay, so I think that's a good explanation of what the fuck is going on, right? So the operator is overloaded, so that's why it always calls and hits the out of bound assert check. So if an array or a structure do not have any fields, it always crashes, right? So I'm not sure if it's grammatically correct, but whatever. Okay, so yeah, this one is a little bit weird. Use percent formatting in it's a GF fields. I'm not quite sure, like how to say that, in like where exactly do we use that? We can say in GF fields recurse, right? In GF fields recurse. So how can I explain that? My version of GDB is so old. It uses Python 2. In Python 2, print how to say that, print array 5 results in, and let's actually literally show, right? So if I do print array 5 results in this thing, results in being printed instead of, and let's see how it's supposed to be printed. I didn't want to open anything. So if I just run it in Python 3 instead of this, which breaks the parsing in, and it would be nice to say where exactly it breaks the parsing. Does anybody remember? Who am I talking to? I'm actually streaming live. All right, so remember there was something like A to I somewhere, right? Evaluate result. Yeah, okay, so here it is. So I think that's basically where, yeah, it was one of those places. I think it's not that place. Which breaks the parsing in watch add fields, right? Since percent formatting, let's actually be a little bit consistent. If I call it like that, let's call it like that in here as well. Since percent formatting works the same in all the versions of Python, it is relatively easy to add. It's relatively easy to add and fix the problem on all the setups. So it doesn't cost anything, right? So it's just like this simple change doesn't really introduces any sort of problems. Right. So let me read it one more time. Use % formatting in GF fields recurs. My version of DB is so old, it uses Python 2. In Python 2, print that results in this being printed instead of this, which breaks the parsing in watch add fields. Since % formatting works the same in all the versions, in all of the versions of Python, it is relatively easy to add and fix the problem for all the setups. So that's the second thing we have in here. Okay, so we have 2 commits in here. Each commit basically fixes its own problem and explains how like the reasoning behind all of that. So I think it would make sense to maybe just clone this entire thing, like fork at least. Okay, let's do the fork. So I have to choose where I want to fork it. I want to fork it for my own repo. Let's create a fork. Okay, good. And so let's wait until it does its thing. And I'm going to do it like this. Okay, so I need to change the origin. I'm going to reconfigure the origin like this, and I'm going to reset it to my own thingy, and I'm going to actually push this entire stuff to the origin. Hopefully that will work correctly. So it is pushing. Seems to be working, seems to be working. All right, so let's compare and pull request. Fix crash on expanding empty arrays. Fix crashing on expanding empty arrays. It's not actually arrays, but empty arrays. Right, so yeah, it was crashing on empty arrays. Yeah. So, but for me, on top of that, it was also just like not displaying anything at all. Okay, so this pull request fixes 2 problems. Right, 2 problems. First is the application crashing when trying to expand empty arrays or structures. Second one, structure. First one is the application. Second one is not working properly on with older GDBs. All the details are in the commit messages. Thank you very much for making such useful GDB front end. So can we put a heart in here? Yeah, there we go. Please let me know if there are any problems with the pull request. All right, so let me double check if everything is okay, and we're gonna create a pull request. All right, so that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you on the next recreational programming session. Right, that was fun actually. I should use this GF thingy more, right? So, and not be afraid of fixing the problems, because I actually encountered that problem multiple times in the past. And that kind of drove me away from constantly using GF2, and this time was the last straw. So I decided to finally fix it, and it wasn't that bad. So maybe I should not be afraid to fix the problems with the open source applications that I use, right? So they're open source for a reason. They're open source specifically so you can look into them and fix any problems that you encounter with them. So yeah, check out the GF2. It's actually very cool front end for GDB, very useful one. And yeah, I see you on the next recreational programming session. I love you all. Mwah!